Hello students. So now in this section we'll see that what data structures we're going to use, how we're going to allocate the memory, especially when we are trying to code it in a programming language like C. So we have seen in case of our matrix representation, it was very simple because we already had a 2D two-dimensional array, right? So for two-dimensional array, we just model it as a matrix and we store the information there, right? We saw that in detail in the previous lecture. But now, how do we, how do we, how we'll represent this graph, which is in form of a list representation. So now let's start building it block by block. So let's take the very basic block, which is a node, right? This node. So now also another thing is that at this point I'm assuming that you have a good familiarity with linked lists. So you have coded linked list, simple code, not expertise, that how you insert a node in a linked list, how you create a linked list, how you traverse a linked list, and how you delete a node from a linked list. So this knowledge should be there now to proceed any further. Okay, now let's see that how a node is basically defined and is created and is given a memory. So if I say a node, so basically this, right? This is my node. So it will have two sections. One will be related to data, where you will be storing some important data. Here in this case, it will be nothing. But it will be just your name, right? City name. And this section, the second section, is important. Here you will have what? An address of your next node. So basically, if this is your next node, right, and let me say that it has a address of, I'm just assuming, A. So when I say that this node is pointing to this node, what I actually mean is that in the next pointer of this node, I have stored this address. And since it is an address, this field has to be a pointer. And pointer of type what? The pointer of type which this address is represented, right? Which is nothing but a node, right? This is nothing but a node. So now what my structure would be? So let me write my structure. So let's say if it is a structure, struct node, right? So it will have two parts. First will be storing my data, that is name of this city. So right now I'll not get into the detail that how I'm storing this data. Just let's assume that I'm using a character pointer variable to store it. Now the next is important. Next part is important. Here I'll be storing what? I'll need a pointer which will be pointing to my next node. So definitely let me name this variable as next, and this variable is a kind of this is a pointer variable, right? So this is a pointer variable. And what kind of pointer it is? Again, this is a pointer of type struct node. So now this is done. So now I'm done. So this is going to be my structure of my node, right? So two parts. One is the data field, another is pointer to next node. Now if I'm interested in using type def, I can just write here type def and I can give it any user defined name, right? So here let's say in this case I gave node, right? I could have given list node also. So the good part is that now next time when I write node or node pointer, it automatically means that I'm referring to struct node or struct node pointer. So I don't have to use this struct again and again, right? And also this could be my uh, user defined or something which user wants to use, like list node or tree node, something like that. Anyhow, so this is how my node will be represented. So I've taken a snippet from the code. When I'll discuss it again, when I'll run through you through the code. So this is what basically I have taken. So this is, as I mentioned, struct node. This is your data part, and this is the pointer which is pointing to your next node. So this is type def, and finally I have named it as node, right? So now, since we have seen this, now we'll see that how do we allocate memory to this node, how we make this node, right? So that is also important, and you must have read this thing in the linked list. So this is all basically linked list going on. So how do we allocate it a memory? So now to allocate it a memory, we'll be using allocating a dynamic memory from the heap, and that is done through your malloc, right? So how it is done? So let's say that if I have a function, right? Let's say create node, and through this function I'll be creating a new node. What will be its parameter? Let's say parameter is simple. I'm passing just the name of the city, right? So the main idea is allocating the memory. So I'll be focusing more on that. So what you will do, you will have this malloc, right? It will be allocating memory. How much? Size of equivalent to that of node structure, right? This much memory is allocated, and it will be typecasted toward node pointer type, right? And so basically what this malloc is doing, so this malloc is taking a chunk of memory, right? Chunk of memory, and how big this memory is depending upon our structure node. So it is referring, so what it is basically doing, it is reserving a chunk of memory, and it is giving the base address. So what it is giving? The base address of this chunk of memory. And where I'm going to store it? Definitely, let's say I'm taking a new variable, new node, right? And since this is the address of type what, of type node, and I am allocating, storing this address in this variable. So this variable has to be of type node, and since this is storing an address, so it will be node pointer, pointer variable. Why? Because it is storing the address. So let me repeat it again. Here what I have done basically, first of all, I know I need to use malloc. How much size? Size of my, how big is my node, right? Because that's what I'm storing basically. That's what I'm creating. So it will be the size of node. Then what I'm doing, I'm passing a reference to that memory location, which will be nothing but the first memory from where it is beginning basically. That memory address I'm passing to a variable. Since I'm passing a address, so it will be a pointer variable, an address of what? Of node. So it will be my node pointer. So this is basically allocating a memory to the node. So if I just take you to this snippet from the code, so here I have done that. So here if I just show you, so here I have allocated the memory, and here basically nothing I've done. I have just copied the name which was passed to this function to this field. Basically I've copied it to the data field of the node and set the next pointer as null, and then return this pointer variable. So that's what I've done. Basically I've allocated a memory and filled the structure node first by the name of the city, and then next pointer as null, because this is the standalone node. So a single node I have created. Now we'll see that having created this node, right? So having created this node, Now how to create this skeleton? So I'll call this this part basically. If I refer to this part, how do we how do we will make it? So let me call it, if this is the spine, right, and this lists are hanging out of it. Now list, we know how to make it, right? And we have already created the basic fundamental unit of a list node. But how do we create this structure, this spine? So now we'll discuss that how to create this basically this array. It appears, right, from which the lists are hanging. So students, we see now we need to see that how to basically what data structure to use, how to allocate memory to this spine, right? So this is important. So let's see how it is done. Now this is going to be slightly tricky. So, and I'll run you through all this in the code in the lab video also, where I'll run you through the code. So this is just to give you a high level picture, right? So if you are not able to understand it, just see it one more time and just get a high level overview, right? So now if we see, if I just rotate this graph representation by 90 degrees, what we have, right? So we have this array, and from each of these the indices or index, or you can say buckets, some list is hanging out, right? And what this list is basically is the number of adjacent nodes to this vertex, which is stored in this bucket of this array, right? So for example, if we had here Delhi, so what would be my list? It would be, let me see, Chandigarh, Mumbai and Kolkata, right? Chandigarh, Mumbai and Kolkata. Now the point is that how do we populate it, and how do we allocate memory? So now let's assume that if we are populating it through a function, let's say there is a function called add edge. Sorry, so let there be a function called add edge. So what it is doing basically, it is taking each edge and then making a graph, right? So, and let's say the parameters are a source vertex and destination vertex, right? So now let's say in this case I am giving it a parameter as Delhi and Chandigarh. Now what will happen? So definitely here, and also I am assuming that somehow I know, maybe through hash function or whatever way, I don't want to go into that detail. Somehow I know that this Delhi is to be placed where in this bucket. So let's say at index 0, it could be very well anywhere, like it could be 2 also. So at index 1, at bucket 2, let's say I know that this mapping is confirmed, that I'll put Delhi here. So now what will happen, since right now this is definitely null, right? There is nothing here. So what I will do is I will create two nodes, and we have seen that function, right, earlier, create node function. So we'll create two nodes, right? One D and one C, D for Delhi and C for Chandigarh, for the two cities or two nodes, right? And then we'll put here this node, and when I say this node D, it means the address of this node. Now this is very important. I'm not putting the whole node structure, I'm putting the address to that node, which is to the memory of to which has been allocated somewhere, dynamically somewhere in the memory. The memory has been allocated somewhere, right in my machine. Now so here I will put an entry to D because it's null and it's a source vertex is D, right? And now C, so where C will go? C will, another node, I'll make C, and I'll, this D will be pointing towards this C, and that's very easy, right? The next pointer of this D, all I have to do is store the address of this C, right? Now another edge, if I add another edge, and another edge I add, let's say D comma M, that is for Delhi and Mumbai. So now what will happen? Now see what will happen. Now I'll go here and see, okay, the entry is there. Now this time I won't create any node for D for my source vertex because it's already there, right? All I have to do is create an entry for a node for M, right? And M I have to somehow add to this linked list. So it's now just a question of adding a new node to the linked list, either to the front of the linked list or to the back. So if I somehow say that this was the head of my linked list, so what I have to do is either I have to add Mumbai here, right? Or I can add it, or I can add it, at the head, right? So my C goes here and new node Mumbai gets added here, right? So it's just simply a case of insertion into a linked list, either to the tail of the linked list or to the head. So in the code I have added to the head of the linked list. So now this operation is clear, right? So now we are just translating, our basically what we have studied into the some sort of a code, pseudo code, right? So this is how edge is going to be added. Now the important point is that how do we allocate memory for this stuff, right? So now let's say finally if I try to make a graph data structure, so I'll make here only so that you can view this thing. Let me delete this add edge function. So now how my graph data structure will look like. Now things are taking shape. So struct graph, right? Let's say I have one field, integer field, which tells me what is the number of vertices in my graph, right? So it's just an integer. Now what would be the another data structure that I'll going to have? So like I have to create space for this one, right? So now how will I create this data structure? So definitely this is an array, right? Let's say this is an array of vertices, right? And this array, what this array is, so this is an array, right? And what this array is storing, basically, this array is storing. Now that's very important. Please pay your attention here. So this array is storing nothing but an address. It is storing an address. Address of what? Of node, data structure type node, right? So definitely this array is storing. So what will be the type of this array? Node pointer vertices. So node pointer will be the type of a array, right? Now it's very simple. Now what will you have? Probably you will have a function called create graph, right? And in create graph, what you will have a parameter as the number of vertices, let's say n, right? And now here you have to create a graph. So let's say if I just create a graph variable, so struct graph, let's say g1, right? Now what I have to do for let's create a pointer type, right? So g1. Now to this also we have to allocate some memory, right? That how we'll allocate, I'll go into the detail when we see the code. But let's assume we have this this pointer variable g1 and some memory is allocated to it, right? So now what you will do here, g1 num vertices, here you will populate the total number of vertex this graph has, or total number of nodes this graph has, right? And this is the array. Now the issue here is in this array is that this is the static allocation, right? So we have to say here either it is 10 or it is 5 or it is 50, right? Now if you don't want to make this also, if you also want to allocate this array dynamically, so what you will do, you have to take you have to use malloc. So whenever there is something dynamic, you have to use malloc. So now if I decide that this data structure, I will not assign memory statically, but I will assign it dynamically. So how I will do it? Through malloc. Now what I will do, I'll call malloc, right? And how much memory do I need? Definitely n times, because n are my total number of vertices. size of what? Now I ask you whether it should be here node or something else. Now see, this I'm allocating space for this array, right? And what it is storing? Storing node variable of type node pointer. And how many? What is how many these variables it is storing? The total number of vertices the graph has. So the total number of vertices the graph has is defined by n, and the size of not node but importantly node pointer. All right, so that I will use. And now what will be the my typecasting here? Now see, when if you have used malloc before, and I am assuming you must have used it in case of a linked list. So if I am allocating a space for int type variable, then what do I return? The base address, right? And I typecast into int pointer, right? Because this is the base address of something which is storing my int, right? So what will be its return type? Int pointer. So similarly here, when I'm returning the base address, when I'm returning the base address, so base address of what? Which is something node pointer. So address of it means I have to typecast is node pointer, right? So this is how I allocate the memory dynamically, right? And now I have to assign it. So now what I can modify here is, rather than the array, what I will have the base address of this one dimensional array, which is storing node pointer. So now I have a base address. So now it will be node pointer vertices. Are you getting this point? And here where this I will, and how I have allocated memory to this, where this is pointing to, that is through this thing, right? So finally what I have to do is here just G1, and G1 has a data type. So G1 vertices, right? So because if you see, this is node pointer type, so it's matching here, right? So basically this is nothing but vertices is what? It is pointing towards the base address where we have allocated memory for this array, which is storing nothing but a pointer, which is storing nothing but a pointer to what? To node type data structure. So this is complex. Let me repeat it again. Here. So what I have done, I'm trying to allocate memory to this stuff, right? This is an array. So how do I allocate it a memory? Total number of buckets will this will have. Now this is nothing but n. What it is storing, this array, this bucket is storing what? It is storing, a pointer variable which is pointing to the data structure of type node. So definitely it will be size of node pointer, because it is storing pointer. This is the total memory. Now what I am doing is, now I am assigning the base address where I have allocated this memory node pointer to a field of a structure type graph, and that's it. That's all to it. I have now all the required data structure and memory with me to start representing the graph, to start adding to this graph, to start making this graph. And one small thing I need to do here is that once I allocate the memory, so what I have to do I have to initialize it. So what I have to do, and how can I access, this individual bucket? So this individual bucket, ith bucket, I have to just, I can access just through this statement, right? So this means I can go to this ith bucket, right? So now all I have to do is initialize it to null, right? And for all I, right? So if if I just show you in the code, because this is very hodgepodge thing, but I hope you got an idea. So if I formally show you how it will look in the code, so in the code it will be something like this. So here is what you are creating a graph. This is a function to create a graph. Now here you have to the graph pointer, which I told you, right? So here you have allocated memory to it, right? Now once we'll code, I tell you that why I've used malloc here, why I cannot declare a graph variable and then assign assign its address to pointer variable given. Why I'm not doing that? And if you can figure it out on your own, that's very good. A hint would be that would be a local variable, but we need this pointer to be accessed everywhere. So that's why it cannot be a local variable, because if it is a local variable, it's it will die outside this function. You cannot return that variable, right? That pointer variable, because its life is in the scope of this function. So coming to the point, so now this is where I want to focus basically. So here, see what we have done. We have populated the first data type of graphs of structure graph, that is the number of vertices, and here, so the input is the number of vertices this graph would have, and this is here I have allocated it using malloc. So here I am allocating the base address of this array, one dimensional array, which I have created using malloc. And finally, what I am doing, I am setting all these buckets to null pointer, right? To null pointer, because I am initializing it. So that's it. So now, and see the beauty, to create a graph data structure, you have to call a function and you are just adding only one thing to it. You're passing just one thing, one variable, and whole data structure is created in these these few lines. So it initially it will look a bit intimidating, but it's very simple. So now probably we have, I think, all the necessary information, high level picture to jump into how to finally code this thing. Yeah, I think we are done here. Probably now the next episode has to be a lab only. So guys, thank you very much. If you like it, just comment there, share with your friends, and just give it a thumbs up. Thank you very much.